Alright guys, so I'm back. Alright guys, for my maths monkeys. Now, okay guys, what we have here is this is basically looking for the volume of this guy. So what you're going to do is you're going to find the area. You find the area in two ways. You can use the S equals your A plus B plus C over 2 formula. And then you can use area equals, what is it? It's going to be S minus A, S minus B, S minus C. And you just simply say A equals 3, B equals 5, C equals 7. You can do that in any order you want. Now, I'm not going to do that today. I'm going to do a trigonometric method. So we're basically studying paper 2 at the same time. Alright, everybody remembers me doing this recently?
Yeah.
Okay, so I'm going to do a different method just to help you revise, okay? So a different method would be that you want to get an angle between any of the sides. So you can pick any angle in this triangle you want. Doesn't matter. I'll pick this one here. Would everybody agree that's going to be the largest angle in that triangle? It's going to be the largest angle because it's looking at the largest side. When I have 3 sides and I'm looking to find an angle x, I use the cosine rule. A squared equals b squared plus c squared minus 2bc cos a. Now because I've chosen the angle I'm looking for, that means I've chosen A. And because I chose the angle, that means I have to choose the side that looks at it. That means I chose small a. B and C are interchangeable. There's no order required. Everybody got that? Now here's what you're going to do. You're going to put down your, 7 squared equals 3 squared plus 5 squared minus 2 times 3 times 5 cos A. This is an angle question, and by BOMDAS or BEMDAS, this is down to the cos A. You can't move it till the end. So you're going to get 9 plus 25 minus 30 cos A. That 30 has to stay with the cos A. Bring the 9 and the 25 over the other side. Take it away from the 49. So it's 49, take away 34. You get 15 equals minus 30 cos A. Now, there was something that we used ASTC, or Anto-Stoltekar. Okay. 0, 90, 180, 270 and 360. Each quadrant has its own set of rules. As an example, quadrant A, every function is positive. However, in quadrant B, only sine is positive. So sine 120 would be positive, but cos 120 would be negative. Okay? So what we do is, for the second quadrant, there's a rule. It's 180 minus your reference angle. In the third quadrant, it's 180 plus your reference angle. And finally, in the fourth quadrant, it's 360 minus your angle. Okay. Sometimes you can take a note of that into the trigonometry section of your book, but then come leaving cert time, you're going to need to know them. Okay. Now, here's what we're going to do. We're going to divide 15 by minus 30. We now know that cos A is negative. And cos A is negative in 2 places. It's negative in the S position and the T position. But only one answer is relevant for us today. Can anybody tell me which answer is relevant? I'll do but it's a triangle, so it has to be less than 180 degrees. But for argument's sake, I'll do both of them for you, okay? So what you do is cos A equals minus a half. But what I'd like for you guys is to just pretend that it's plus a half. So always cos inverse plus a half. Please make sure you're in degree mode, the D, not the R.
Why don't they do minus half?
I'll tell you now. I get 60 degrees. This means the answer would be 60 degrees if it was positive and in the first quadrant. However, we now know that A is 60, so now we can use the rules to find out the other answers, okay? So it's 180 minus 60, which is 120, or it would be 180 plus 60, which is 240. But it can only be the 120. That makes sense?
Why do you need the minus?
If you cos inverse minus a half, it's just a calculator quirk more than anything, I'm afraid. See the way it gives you 120,
Yeah.
which is the correct answer.
Oh,
But there's no way to find out the 240 then on a different question.
Yeah.
So that's why I use this method where you
always use a positive.
always use the positive number
And just take
and
it.
then use your 3 rules. Okay? Now guys, now that we know that x is 120, everybody see that x is 120? Can anybody tell me how would you get the area of this triangle? Half AB sine C. No worries, somebody do that for me in the calculator. So I have 3 times 5 sine 120.
Is AB always two ones that it's not facing?
Yeah, it's an angle sandwich, so you use the two sides and the angle in between.
Cheese toast.
That's
6.5.
6 point what? 6.5 centimeters squared. And as discussed in the recent now guys, we have the area, but we haven't got the depth. So what do we get here, guys? 6.5 multiplied by 10, which is 65 centimeters cubed. Right? That's the trigonometric method. I'd actually recommend you try it out that way, just to revise your trigonometry. Okay? Let's go again. Now this one is an odd one. A megaphone in the shape of a cone has a vertical angle of 60 degrees and a slant height of 45 degrees. Determine the diameter of the megaphone, determine the volume of the megaphone. Okay, so what we're going to do here, guys, to make this really easy on ourselves, it's just a very simple little trick. Just going to grab your diagram and just turn it upside down, just turn it vertical. I'll do a better one in a second. There we go. So just grab your diagram and then just turn it around. It's obviously a circle. So there you go. Match tricks, alright? Now, what you're going to do is the centre of the circle has to be directly beneath the peak of the cone. Therefore, when we cut the cone in half, we have now, we can't find out what the radius is because we technically don't know this height here, do we? Pythagoras' theorem is out the door. Do you got that?
Yeah.
Cannot do Pythagoras' theorem.
Is the angle 30 then?
Angle's 30, and it's a right angle triangle. Okay?
So opposite over.
So you're now at SOHCAHTOA level. Okay? So the angle looks at, this is the opposite, and this one is the hypotenuse. So sine 30. SOHCAHTOA, so you have to use opposite over hypotenuse.
4 over 45.
R over 45, and then R equals 45 sine 30, which is 22.5. Okay. Next thing I want you to do is look up the you want the size of the megaphone in liters, don't you? So to the two significant figures. Everybody remember what a significant figure is?
Yeah.
How many significant figures here?
2.
2. How many significant figures here?
3.
3. You got it? How many significant figures here? 5. When the zeros are sandwiched in between, they count as significant figures, but when they're at the end, they don't count as significant figures. Okay? Now guys, what we're going to do next is we're going to find the volume. So what's the volume of a cone? 1/3 pi squared h. So we got the calculator for this. We got the calculator. 1/3 pi. Oh, we need the. Oh, we're lacking the h value, aren't we?
Yep.
So you can do Pythagoras, or there's another one. You could call this x, which is the adjacent. So instead of looking for the opposite, you're now going to use cos 30. And what are you going to use cos 30 for? Adjacent divided by hypotenuse, which is x over 45. And then x equals 45 cos 30, which is?
Same. Oh no, 39.
What you get?
38.97.
38.97, okay? Now that's 38.97. And what I'd like you to do next is we're going to fill out this area of cone, volume of cone, phi cone, is a third pi r squared h. So third, our r value is, what do we have for our r value earlier?
22.5.
What? 22.5. A third pi 22.5 squared, and then 38.97 squared, 97. What you get? 20,659.7 centimeters cubed. To turn that into litres, guys, remember 1 litre is 1,000 centimeters cubed. Divide. Litres are bigger than centimeters cubed, so divide by 1,000. Yeah. 20.659 litres. Are you asked to round it off to anything to that? Two significant figures. 21 litres. Okay, that's currently 5 significant figures. Right, so 21 litres with the 2 significant figures. Okay, guys, I've done questions 2 and 3 so far. Now I'm on to 8. Now, we have a house, it's 7 by 8 by 12. Show that x equals 5.66, correct to 2 decimal places. So what we're essentially going to do here is, see the way that's 8, how do we know that's 8? It's a rectangle. Pythagoras' theorem will tell me what then? 8 squared equals?
X squared.
Plus x squared 64 equals?
Pythagoras.
Is Pythagoras. See that 8 is the hypotenuse and the other 2 are just 2 regular sides. X squared equals 32. Square root of 32. I'm hoping it's 5.66, otherwise we're in trouble. But 5.66. Alright. 56.06. Now, hence, calculate the volume of the house given your answer to nearest cubic metre. Well, what can we say about this one here? Actually, we can get this, can't we? Half base by height. It's right angled, isn't it? So, what do we say? That's so essentially, if that's 5.66, if it's a right angled triangle, you can do base by height. So half 5.66 by 5.66. That makes sense? So would everybody agree that it's 16? It was 32 earlier, divided by 2, 16. So that face is 16. Is everybody happy with that? How deep does it go? 12. What's 12 times 16? 192. So it's 192 for the top part of the house, which is this part here. Please, in exam you'd have to write down volume equals area times length, and you'd write down phi equals 16 times 12 equals 192. Right? What about the rectangular bottom then? Rectangular bottom's easy, isn't it? Yeah. 7 by 8 by 12. What do you get? 672 plus our 192. 8 what?
864.
Yeah. Everybody cool with that? That's probably junior cert-ish, a hard junior cert question. We'll move a bit higher. Okay. Find the volume of a cylinder of radius 6 millimeters and height 20 millimeters. Give your answer in 2 forms, in terms of pi and correct to 2 decimal places. Okay, what's the cylinder formula? Anybody remember the cylinder formula? Volume of a cylinder? Pi r squared what? H. Okay, pi r squared H. So what we getting here? Pi times 6 squared times 20. Somebody give me in terms of pi, and then give me into 2 decimal places. Oh, pi, sorry, the 20 is not squared. 720 pi, and in millimeters squared, or sorry, millimeters cubed. And what is it in terms of 2 decimal places, no pi? Press the change button.
2261.95.
2261 point 9.5. Am I right saying I did 2, 3, what's the last one? 8, and now I'm doing 10. Alright, just keep an eye on that. Now, what's the next thing he wants me to do? They have a box to contain the cans in, okay? And it measures 60 by 35 by 20, so that's 60, and I reckon that's 35. Okay? 60, 35 by 20. Cylindrical holes of radius 6 millimeters are drilled one at a time through the block in the direction shown. Okay? After how many holes will more than half the original block have been removed? Just get the volume of the block. What's the volume of the block? 60 by 35 by 20. Just do that in the calculator now. Volume of the block is 60 by
42.
what you get?
42k.
42,000. Okay. Now, 42,000. Would you agree with that?
What do you divide by?
Now, just give me a sec. Half of it, if you remove half of it, you got to remove 21,000. Would that make sense? Now, what I'm going to find out is how many cylinders does it take me to make 21,000. So 2261.95. What I'm doing is I'm dividing the amount of volume of metal I have to remove, divided by the size of chunks I'm removing at a time. Okay. So what are the two numbers divided by each other? What you get? Anybody?
Minus 9.284.
So 9.284. Now here's the problem. 9 cans won't do it for you, or 9 cutouts won't do it for you, because you'll still be below halfway. So technically 10 full cutouts will get you more than halfway. Does that make sense? Alright, just stop it there.